Good afternoon, everyone. This concept, which I think everyone here, of course, is looking forward to know a little bit more. Right? So today we're going to be talking here about using PASOE as a Docker container with Kubernetes. We're going to be looking first at the difference between Docker and virtual machine. Now, how many of you already know Docker, some of Docker? Okay, all right, that's a good number. What about Kubernetes? Okay, some, good. All right, now we're going to also walk through our deployment architecture, what we're doing for Docker, the Docker container for PASOE, and look more in detail at the Docker container image, and also then we will have a demo. How many of you, I don't actually recognize anyone that attended the workshop on Monday? Okay, so we'll have some few. We're going to do a similar demo to the one in the lab, right? But this is the time where we are going to focus on the material for this component. Well, we started with this mission, with this idea, to deploy and upgrade PASOE in business application, in production, just with the push of a button. That's what we wanted to do, how we could make that possible. Well, and we know, of course, that the technology is out there. Docker is what gives you the encapsulation, the isolation for your applications, and can get us up there. Well, let's take a look now at the Docker and virtual machine configuration, right? Many of us, I think everyone probably, right, knows virtual machines, right? So the concept of a virtual machine, we have a host machine, maybe your laptop, maybe now you're running, you have the infrastructure, your host operating system of your laptop, and then the hypervisor, right? We're working, let's say, with VirtualBox, Microsoft VM support, right? Parallels, perhaps. And then we have virtual machines running on top of this infrastructure, right? So in this case, we have maybe multiple virtual machines where we have a guest operating system, the binaries and libraries that are used for the application, and then the actual application. And this is our VM box, right? Now, when we work with Docker and containers, the concept is a little bit different. Well, what is the difference? Well, we don't have a guest operating system. What we do is we work with the host operating system, the same operating system that runs the Docker engine. And the Docker container, right, and here's just a part of the terminology, right? You build a Docker container image or an image, and then you run it, and that creates the container. So the image is the presentation of your file system, let's say, on disk, and the container is the presentation in memory. So we don't have a guest operating system. In this case, we use the one from the host operating system, and the idea is that we build this image where we provide the binaries and libraries that our application uses. And now we distribute the image of our application. And we install it in a Docker environment, and then it runs just as we have it in our CI/CD pipeline, let's say. Okay? All right, so the deployment architecture here, we're going to see this model, right? So this is just a way to think of the classic OpenEdge applications, let's say, right? Well, how we do that? Generally, you will have, let's say, the pieces of your application, PASOE, your data service, in this case, PDS stands for Progress Data Service, not Progress Development Environment, right? And we have the web UI. we have the business entities and the database. You can have everything on one machine. Of course, you generally would work with an N-tier type of application where the components of your application would be distributed in multiple machines, right? So you have one machine running the web UI, another machine running the data service, and another machine running the database, right? That's the N-tier. That's just a traditional application. And you can access it from multiple clients. You're using HTTP type of connections to access it. GUI clients, HTTP clients, mobile clients, native script, or even Node.js TypeScript. When we work now towards a Docker architecture, now we're actually working with containers. Right? You may still have the database running on a separate machine, but now your web UI perhaps is running in a container in a pod. Right? This actually, in the terms of Kubernetes, is running on a deployment. Well, for PaaSOE, we also are running on a container in a pod, and then we can have here, right, that is the application server, PaaSOE, PDSOE, running inside a pod, and we can have multiple replicas of that instance, right? This is a Kubernetes deployment. There is a service that gives access to the data, and then there is an ingress, which is a concept in Kubernetes to expose the service to external clients, to remote clients. Yes, Frank?
They have to run the PaaSOE instance, have to run on a different port?
No, it doesn't. So this is an interesting concept. Let me just expand a little bit on that, right? So the container, right, is its own, like a virtualized process, right? So it's not a virtual machine, right? We know that already. It's more like a virtualized process, and you can have PaaSOE running on its regular port, 8810 or 8811 if you're using HTTPS, and then you say, in order to access it externally, right, I'm going to use this port, right? In fact, when working with Kubernetes, right, Kubernetes allocates a port for the service. Well, if these are all services in the same application, right? Well, actually, you are doing this here is like a load balancing type of thing. So any replica is just fine, right? So you use the ingress, and Kubernetes then sends the access to one of the pods. Yeah.
So what's the load balancer?
I'm sorry?
What's the load balancer?
Oh, the ingress support. Yeah. Mm-hmm. And you can use other load balancers as well. One key piece of information here, in this model, we are doing like an image with the PaaSOE and the PaaSOE application together. There's another concept called the sidecar container pattern, where you can run PaaSOE, just the PaaSOE instance, let's say, and then you have your actual application in a separate container. Okay? Different models. Well, the Docker container for PaaSOE. Let's learn a little bit more about it. So we started this project perhaps almost like about this time last year. DockerCon was just a few days ago. We also had people in the team going to DockerCon last year. We did a lot of research, we learned, and then we implemented the Docker container for PaaSOE. And we made it available for 11.7.4, and of course, it's now also available for 12.0. Now, one key component about this, right, is that we're creating a baseline container that already has PaaSOE installed, right? So you don't have to install PaaSOE. It's already in the image. You just need to run it. It's like a package, like a box that already is ready to run, okay? So PASOE is pre-installed. You create custom images, either an image with your application or using the sidecar container pattern, and you use it with your CI/CD process, okay? We added a number of little features to make all this possible. So one thing that we're doing is that the image is something that we distribute, but it doesn't include a PASOE license. You provide the PASOE license, right? There's a way that you can go to the customer portal and generate the CFG file for using with PASOE. It's the same as your installation of PASOE. So if you install PASOE and you have the CFG file, you can use it with a container. We made the image lightweight, meaning that we aim to have like 800 megs in size for the image. The idea being is that we want them to make easy to copy over the network, or perhaps if you're using something like EKS, right, with Amazon. We made the file permission and the user settings to be the PSC admin user in the container. The idea is that, like when you install OpenEdge, right, well, you install it as root. And sometimes you run it as root as well, right? But in this case, we wanted to run it just as a regular user to make sure that we're handling the security at that scope. HTTP only by default, HTTPS only by default, which means is that if you install it or you use the image, now the service that you use to access is HTTPS, right? So there is already encryption happening there. If you're using Kubernetes and with the Ingress service, it already provides the HTTPS access, so maybe you don't necessarily need it that way. We have an image version file that helps you to identify what version of the container you are using, okay, for OpenEdge. And we added support for EFK, Elasticsearch, Fluent Bit, and Kibana. Well, what happens is that when you work with containers, right, well, you're not working with just one running container. Most likely you're going to run with multiple instances of that container, multiple replicas of that container, right, with a load balancer type of approach. And also, well, maybe you don't have just one deployment, you have multiple deployments. So what do you do in order to manage the environment? Well, one way that we did is we added support for the EFK stack so that the log files from PASOE are gathered by Fluent Bit. It gathers the log files, right, in each of the containers, gathers that data, ships it to Elasticsearch, and then from Elasticsearch, you can query that with the Kibana interface. So it's a way for you to manage that. And we have some samples in Progress community on how to do that. Well, we made the container first to work with Linux, and we focus on working with Red Hat Enterprise and Docker Enterprise Edition, and you can also use it with Kubernetes. You can use it on Linux in other environments, like for example, we tested just for the workshop running with EKS, which is Amazon's Kubernetes support. We also work with Minikube, right? But it depends on what you have in the environment, okay? I'm sorry? Oh, yes. Yeah, no, it works with the CentOS. So in this case, notice that CentOS is actually the host operating system for this, right? So in fact, what the images that we generally build are Linux CentOS-like, right? And then you have CentOS, and you have Docker, and then you install Kubernetes. Mm-hmm. All right, some resources here. You have information available through the ESD. That's where you can download the image. You have the documentation available now at the docs.progress.com, which is the new documentation hub. And we also have information available in Progress community. And here are the links for that part, right? So we have one sample application that we built with Docker and 11.7, and another one that we built with 11.7 and EFK, right? So we want to have that available, right? What is the difference? Well, this one didn't have the EFK support. It's easier to perhaps start playing with it. The EFK is not really that complicated, right? But it's another example that you can use, okay? And we added a little FAQ that you can also use, okay?
How do you deploy a REST service to a passive that's on the image?
Right. And I think you mentioned a very important keyword. How do you deploy to the Paso image? So what we do, and that actually goes right in line into this presentation. Have you seen this presentation before? No. So it goes into working with CI/CD. All right. For those of you and us, I was there too, that saw the presentation on CI/CD, right? Well, you have that you want to go from the CI/CD perspective, right? You want to build, test, go to the staging and production with the same image. So you build a Docker container image at this stage. You put it into the repository manager and you test with it. And then you promote that very same image into your staging and then your production environment. You want to use the same image, which then means is you don't deploy to the running instance, you build an image that already has your deployed packages, your deployed application.
So you take the original image and then overlay it with your...
That's correct. So
You cannot have your REST services in a separate container or Docker.
well, your REST services would be that container image for the application, for the data access. Yeah. All right. And when you want to deploy, you can do something like rolling updates, which is what we are going to show you in the demo. Okay? All right, so one thing that you need to do, it's very simple. You have the Docker container image for, in this case, that's supposed to be 12.0. Okay, we didn't do it for 11.7, 4, and 12.0. And then you do Docker load of that image, right? It goes into memory. The next thing that you do is you create that custom image. And to create a custom image, you use a Docker build command. That's how you do it. You can also do Docker compose build if you're using Docker compose. And there are like different, let's say, approaches to things, right? Like this is a new concept for some of you. And you have to kind of build your own path into it. Work first with Docker, plain Docker, then maybe experience Docker compose, and then go into Kubernetes, right? So that's, you need to kind of walk that path. And Docker compose is a way to manage your definition of like a deployment, and is something convenient to use. And if you're using Docker Enterprise, it actually can use the same format to deploy into Kubernetes, because Docker Enterprise has support for Kubernetes. Okay, so the next part here, and some pieces to highlight, is that if you're using plain Docker, you would run it like this: Docker run DIT, detach interactive terminal. And this is the way that we currently work with this model. And there is also a you generally would use a P for publish. This is actually, Frank, what you mentioned earlier, right? So the ports, if you're using plain Docker, this is the port that is inside the container, and then you use a port that you map outside of the container, okay? When working with Docker. When working with Kubernetes, it manages it for you, okay? Well, the next piece here is the Docker file, right? So the Docker file is a definition where you have the instructions that tell Docker how to build the image. The image, if you look into what it is a tar file. A tar file that has the structure of your files just laid out, okay? Docker does some additional magic there. There's a specification for it, but you can just imagine it's like a tar file. It's not a zip file, it's a tar file. And what you do is you have this Docker file that when you run the Docker build command, right, and we have a sample of that in the demo, Docker is going to process this file and say, okay, I need to set the environment, I need to now run passOE, passman, create, and then the name of the instance. And I need to copy some files into the instance. I need to now add some additional files into the instance. And eventually, which we have in the next page, you would do a tcman deploy. So imagine if you are like building a passOE instance manually, right? What you do? Well, you do the passman create, and then you do a passman deploy. Well, now you want to do this, but programmatically, right? So you write it in the Docker file, and then when you run the Docker build, it processes that and creates the image with that.
So it's basically your shell installation.
Yes. Yes. And if you already have installation scripts, you can run it from there as well. You just need to be in the environment that Docker can run. Yeah. There's another file that we use, right? So you have created a container image that has the file system structure. Well, now you want to run it. So Docker will run that image. And there is just a file that you specify to Docker. In fact, when you specify here on the Docker file, you have the command and say start pass instance. So at the end of this definition, let's say, it's command and definition, because this actually doesn't run when you build. It's an instruction for when you actually create the instance. That tells Docker to run the instance and then run this program at the very beginning, right? So that means that what we want to do when the container starts and what we want to do in practice is a tcman start, right? So if you were to just typing things, right? So imagine now you want to do the tcman start, but now you tell Docker, this is what I want you to do when you run the container, okay? And there are other instructions here, because in the concept of Docker, the idea is that you run the container actually virtualizes those processes, right? They're running actually. If you do a ps-ef on the machine, you see the passOE Java processes right there, right? So you see it, you have seen it, right? So, and what happens then though is there is a protocol for Docker to communicate with the container when you want to shut it down. So we added some additional instructions to be able to do that. And here are some of the instructions in order to work with Fluent Bit. Okay, so you need this part as well. So you can work with the Docker file for building, with a Docker Compose. In this case, this is a sample, if you want to use Docker Compose to start. Now, the new thing is to use Kubernetes to do this. So with Kubernetes, the idea is that we have a deployment file. Oh, I'm getting attached. Don't want to move. We have a deployment file, right? And this deployment file provides the Kubernetes resources, the definition of the resources that we want to do. One resource that we do is what is called the deployment. The deployment, here are some instructions, and one of the definitions that we have here that is key is the name of the image that we want to run. This is the PASOE with the application. If you're using the sidecar container pattern, it's slightly different. We have an environment variable, DB server, that is pointing to where your database is. You can do it in multiple ways. You can have a PF file instead of an environment variable. But the idea being is that you want to build an image that is independent, is location independent, right? You don't want to build an image that says, always look for the database at this IP address on this server, right? Because otherwise then you cannot move it through your pipeline and deploy it to a customer, right? So you want to make it variable. One way to make it variable, dynamic, is by using the environment variable. There's also a couple of pieces here. There is a concept called a readiness probe and a liveness probe in Kubernetes. And this is, in this case, I'm just using a very simple example of what you can do. But the idea is that Kubernetes then now knows when a deployment of PASOE, in this case, is ready for servicing clients, right? So in this case, how do you know if it's ready? Well, because I run this URL and I can get that data, okay? So that's a way for us to tell Kubernetes, yes, my deployment is now available, okay? All right. Let me go this way, perhaps it's easier. So the next thing that we want to do here, right, is, well, we have the Docker build. This is the full command that generally you would build. And then the deployment command, okay? That deployment, of course, as I mentioned, are the resources for Kubernetes. In the demo, we're actually creating 3 types of resources: a deployment, a service, and an ingress resource, okay? Here's a screenshot of how that looks. We're going to do that during the demo. The general idea for the demo, right, is that we have this screen. This is, let's say, version 1 of the application. And in version 1 of the application, we are going to show the data in uppercase and also only read just a few number of records, okay? Just a few records. Then we're going to build a second version of the application with the Docker build command and deploy over the existing running deployment of the application. To do that, then with Kubernetes, we do a set image command, right? So we use the kubectl, some people like to call it kubectl, and then do set image, which will tell Kubernetes, now start the new image. Okay, so this is what we're going to do during the demo. This is the screenshot on how it looks like. We will see that in more detail. And then we are going to get version 2 of the application where the casing of the fields is just a regular casing that we expect, and we have a larger number of records. And let's go into the demo. All right. So to do that, actually, I'm going to duplicate the screen. So just allow me to do that. Okay, great. So here is a connection to an Amazon machine. This is running Minikube, and these are actually the exercises from the workshop that we had on Monday. That material is going to be available, so you can actually run this script as well. And it's not part of the material today, but I'm going to add instructions on how to build this environment so we can use, let's say, CentOS or any other environment that you have and create it yourself. Okay. So in this case, I'm on this PASOE K8s scripts. Just for simplicity, I added here a number of scripts. Actually, let me show you. We have multiple scripts. And we're going to start from 11. So some go up to 11. We start from 11. And we show here the code for building the image, right? So that's that Docker build command right here. So let's run that. And there it goes along, takes the Docker file, reads the instruction, and executes it, and creates the image. Okay? Depending on how complex, let's say, your process for creating the application is, it may take 1 minute or 2 or more, right? But here we have it. So now we have here version 1 of the application. Okay? And we can see that that one was created less than a second ago. Okay? All right. Now let's do the next step, right? So we have here the next step, which actually we're going to skip that because we already have the database running, so we don't need to start it. I'm going to show you the next step here, which will be to deploy this application image. The deployment is just that kubectl create PASOE deployment. You can also use kubectl apply PASOE deployment. So we just run this. From the workshop, we actually have a chance to change the DB server, just part of our configuration file. But here we are all set to go. And then it starts. And notice here, so we started PASOE deployment, 0 of 2 pods, right? So we have it here, 0, 1, the container is created, right? And now we have PASOE deployment, 0 of 1 running. It's running, but not ready yet. How does it know? Because it's using that readiness probe in order to detect that PASOE is ready to serve clients. Because it needs to start Tomcat, right? It needs to connect to the database. And now we have 1 of 1 running, 1 of 1 running. So basically we started 2 replicas for this deployment. And if we look at this data, we also created services. And this is the information for the service. Tomcat Kubernetes, sorry, allocated a port for it. And we also have an ingress. And the ingress already has here an IP address for external remote access. So let's use another script just to check that we can access the data. So let's run this script. The idea is that we're using the curl command, just a simple way to access the data using HTTP, and we run it, and there we can access that data as JSON. So in our environment, if we look at things, we have kubectl get svc, right? And we can do kubectl get ingress. And we have basically an ingress for the UI and an ingress for the data service. if we go to our web browser, we can now access the data. Okay, and there it is, right? So we access the data with uppercase and the number of records there, 83. Okay. All right, so now we have a running application. It happens that we need to deploy a version 2 of the application. So let's work on version 2 of the application. So for that part, right, we're going to look at another script. We're going to do the same thing. We're going to build version 2. So let's run that. And in here, it ran, okay? One thing that happened, notice that this time it ran like much faster. Well, what happened was in my setup, I actually happened to have a previous version of the version 2, right? And in that case, Docker actually used the cache data. But Docker actually identified that there was the very same thing as before. But that's okay. And here, now we have the next step, which we want to deploy using rolling updates. So with the rolling update approach, what we're doing is a set image, okay? So this is what we want to do, set image deployment. Let's actually run the command. And there it says running. And notice what happens here. So we had 2 PASOE deployments running. So Kubernetes is keeping one because in the instructions that we gave Kubernetes through the deployment definition, we said keep at least one replica running in order to serve clients. The second one is terminated, then it's creating the container, and eventually it finishes doing the rollout. Now we have the one that was starting, right? That 9x is now running, and there is also a second one that is running. The one that was running before, that Kubernetes was keeping running, is now terminating, right? So the idea being is that when Kubernetes is doing the rolling update, Kubernetes can keep the high availability to access your application. So in that case, of course, you still would see version 1 of the application. But now, if we look here, Kubernetes is using version 2 of the application. So to do that, well, now we can actually just go into our web browser, do a refresh, and then we should see the new data. Voila. Voila. Wow. Merci. Je ne sais pas. Yes, please.
I saw on your build that it said Nginx. Where does that play into?
Right, so the Nginx piece is actually the web UI, right? So we're using PASOE, in this case, only to serve the data as REST. And then the web UI, which is that Kendo UI screen, we're actually serving it with Nginx as a web server. Yep. Right, so in this case, Kubernetes has an ingress defined, and behind the scenes there's something called an ingress controller. And in particular, we're using an ingress controller that happens to also be Nginx. Okay? All right. So now we have deployed. Well, what happens if there is an issue? Well, if there is an issue, something that we can do is actually do a rolling back of those updates. So we can run this Kubernetes command and say, roll out undo, to tell Kubernetes, set things as before, right? And then Kubernetes does its work, similar process, right? If we refresh the UI at this time, right, notice that this refresh still shows the version 2 of the application because Kubernetes is still working at it, right? And as soon as new replicas start being available, then you can see the new, well, in this case, the version 1 of the application, because we're doing the undo, right? And then we can do the refresh. And in this case, we're back to version 1, because in this case, that was the need that we wanted to do. Now, one more thing that I want to show you is, and inside is 2020. So here we have the 20 scaling a deployment. What we're doing here is showing the command to do a scale deployment. So we run kubectl scale, and then we say replicas equals 3. So what we're doing is we're telling Kubernetes, now instead of 2 replicas, I want to have 3 replicas. And Kubernetes then is managing through that ingress controller, right, the ingress, the load balancing and accessing the replica. So you will have 3 replicas. It doesn't matter which one you access, right? And then it just uses an algorithm in order to provide the access to the data. Okay. All right, so let's run that command. And we do this. So Kubernetes now is running the command, right? So we have one PASOE that is running, one that is now creating the container, the GX, now that GX goes into running, but not ready just yet, right? We have 0 of 1. And now we say 1 of 1 also running for this pod, okay? And if we run the kubectl get deploy command, we can see that the PASOE deployment has 3 replicas out of 3, right? The 3 are up to date, the 3 are available. So, and in that way, you can scale your application just like that. Okay. Well, that is let me go back to the extended mode. All right, so there it is. So that was the demo time. And now, well, what do we do with all this information? We saw PASOE, working with Docker, working with Kubernetes, working with deployments. Well, we have all the pieces that we can do a deployment, right? We can do production with PASOE, with Docker. We have that baseline image for PASOE with 12.0, working with EFK support as well. We can create the custom images. We can use the sidecar container pattern if we want, and we can use it as part of our CI/CD pipeline, right? Because, again, the idea being is that you build the image and then you promote that image through your process. Maybe you have different pipelines. Maybe one pipeline is only creating the Word file. That's okay. But still, when you want to go into production, what you want to really exercise is that container image, right? If you're, of course, working with Kubernetes. Okay? All right. So with that said, let's open for questions. Can you do the rollback without Kubernetes? No. No, I don't believe that there is a Docker command that does the rollback that way. And with Docker Compose, which is the other alternative, no. Now, there is yet another alternative, though, right, is if you don't want to use Kubernetes, you can use basically the Docker support for Docker Swarm, which is Docker built-in orchestration support as well. And I haven't used it as much, but I believe that one may have that undo operation. Okay. Thank you. ECS? Well, AKS, right? So the Elastic Kubernetes service, right? Probably have that also that way. Yeah. Okay, great. Thank you. Yes?
So is one of the main advantages is there's no downtime?
Right. Correct. Because the idea is that you are running Kubernetes, it's running all the time, right? Kubernetes manages the access to it and the rollout of those updates. Of course, you have to use certain techniques in order to make that possible, right? So like, for example, well, what about the database, right? Frank, you probably would ask about that, right? So what about the database? Well, you want to make sure that your changes, right, in this case of an application, perhaps you're doing changes that are backward and forward compatible for your database so that you can switch from one version of the application to another without impact. Okay. Another thing here, just one thing, is that with Kubernetes, right, in this case, I show the diagram. Well, we had the containers, we had the pods. The pod runs into a node, and you have nodes with multiple nodes, and then you have a cluster, right? And Kubernetes manages all of that, right? So basically, you could say, well, I want not 3 replicas, I want 10 replicas. And Kubernetes will have maybe 3 replicas in one node, 2 in another, 1 in another, and that provides load balancing and also high availability. If one of those nodes crashes, well, you have 2 other nodes that are available. Yes, I believe you're right. I mean, you have to, you're running a process. You're running a process, right? And with the process, you are in a virtualized environment, right? So generally what you do is you have a node that is set up to have the requirements that you need for your application. So like in this case, this VM, right, actually has 8 gigabytes of RAM. So I'm running 3 replicas of PASO-E with 8 gigabytes of RAM. I think that actually is a good use of resources. If you were doing virtual machines, then you probably would have 3 VMs with 8 gigabytes of RAM on each. Okay, all right. Yes, thank you.
So I have a friend that has bugs that go out into the system. It's not me, it's my friend.
Yes. The reason for that, right, you want to go back to the beginning on your CI/CD pipeline and build the container, right, is because just a matter of principle, right? You don't want to fix something in an environment that, in this case, right, as being Docker and being Kubernetes, right, is dynamic, right? So like you saw the configuration, right? You just shut down containers, terminate containers, a new container starts, right? It has that behavior. You could actually go into the running container and change things, but that would be just in memory, right? And then when all this happens, it's gone. And well, even if it was there, you don't want to depend on that being there, and then one day actually you reboot the machine and it's gone, right? So you want to go to the very beginning, build the image, and run it. So, well, by the way, thank you very much. I mean, we're running over time, but anyone that wants to stay with questions, it's great. Thank you very much. Thank you.